Hello students, so we are starting with our next topic, that is operations performed on lathe machine. So we'll see different operations that can be performed on lathe machine. So let's start with this topic. So first operation that will be performed on lathe machine, that is a metal removal or machining process on lathe machine, it is the turning. So this is the first operation that can be performed on lathe machine. So if you see, turning is the lathe operation in which we can reduce the diameter of the cylindrical job, or I can say we can reduce the diameter of cylindrical workpiece to a desired dimension. So the turning is the you can say most common operation where we can reduce the diameter into an desired dimension of any cylindrical job, or you can say any cylindrical workpiece. So if you see, this is the diagram for turning operation. So here we have a diameter D1. We reduce this diameter to D2 by using the turning tool. So that turning tool is called as a single point cutting tool is there. So by which we can reduce the diameter of the job or workpiece. So if you see, workpiece is rotating in this direction. So the workpiece is always rotating and the cutting tool is feed in this direction. So against feeding, it will cut out the material from this diameter D1 to diameter D2. So in turning, the workpiece is held between the lathe centers or in a chuck. So either the workpiece is held between two centers, that is live center or dead center, or sometimes it is held between a chuck. So it is generally three-jaw chuck will be there. Okay, so which hold this workpiece position. Now the tool, it is clamped to the tool post. So we have seen the different parts of this lathe machine. So tool is clamped to the tool post. So the workpiece is rotated part, or the workpiece is in rotation, and tool is fed parallel to the axis of rotation. So if you see, this is the axis of rotation. It is rotate about this axis, and workpiece is again fed to the parallel to this axis of rotation. So workpiece is also fed in this direction. If you see, this is the diagram for turning operations. So here the workpiece, so workpiece is rotating. We have two centers, one is live center and dead centers. So sometimes we use both centers. Okay, so we have live center and dead center, and the turning tool will fade in this direction. So it will reduce the diameter from this diameter to this diameter. Okay, so this is the we can say schematic diagram for turning operation. So we will see this turning operation in image also. So if you see the turning operation resulting in same diameter over the full length. So the diameter is same over the full length of the workpiece. So if this is the full length of the workpiece, so diameter is again same for the full length. So it is called as a straight turning. And sometimes we have the diameter reduction in different lengths. So for example, here is one length, then here is another length. So it is called as a step turning, or it is also called as a shoulder turning. So in straight turning, the diameter is same over the whole length, while in case of step turning, the diameter is different for different length. So that is called as a step turning. So if you see, This is an example of step turning. So if you see diameter is different for this strength, then it is different for this length. Again, this is different for this length. So it is an example of step turning. So here the chuck is there. So the this workpiece is fixed in this chuck. And as spindle is rotating, this workpiece is rotating. And this cutting tool. So this is the cutting tool which is fixed in a tool post. So it will reduce the diameter. When it feeds against this direction, it will reduce the diameter. So this is the first operation that is called as turning operation. So it reduces the diameter of the workpiece. That is the main important thing in this turning operation. Now, next operation is the facing. So if you see in facing operation, we can say the diameter is not reduced, but we reduce some length of this workpiece. So that is called as a facing tool. So in facing, end of the workpiece is made flat. So if you see this end of this workpiece, it making a flat surface. Okay. So by this facing operation, sometimes it is used to reduce some length along this direction. So it is called as a facing. So the workpiece is held same in the chuck and it is also rotated as like in turning operation. So workpiece is rotating and your tool has operation that is feeding in this direction. So it will flatten the edge or end of the workpiece. So the tool is again held in the tool post. Now feeding in this is perpendicular to the axis of rotation. Now this is the main important. In case of turning, the feeding is parallel. Now here the feeding is perpendicular. So here the axis of rotation is here and the tool feeds from this direction to this direction. So in perpendicular direction. In last time, it will feed in this direction. So it will reduces the diameter. But here the tool is feeding in this direction. So it makes the one end of the workpiece flat. So if you see this tool, now this is the axis of say rotation and the workpiece is shown this perpendicular axis. So by this method, we make this one end of the workpiece is flat. Okay. So that is called as a facing. Now another operation that is mainly used, it is called as a chamfering. So again, same, there is a chuck. In that chuck, workpiece is rotating and the tools is again fed. There is a tool this again fed in this direction, that is perpendicular to axis. So in chamfering, a bevel or small taper shape, it is formed at the end of the piece. So at this end, now this, in this, if you see in facing, we have these sharp edges. So to remove these sharp edges, we make the chamfering operation. So the workpiece is rotating. Again, tool is perpendicular to the axis of rotation as like facing. So we have a chamfer tool. So that tool is known as chamfering tool. And we reduce a diameter, small reduction in diameter. That is the small reduction in diameter that is called as chamfering. So chamfering is the process of removing burrs. Now burr is nothing but the particles of the operations. After the operations such as knurling, then turning and thread cutting. So for that we use this chamfering process. So if you see, this tool is called as a chamfering and this edge where we have done some small taper shape end of this workpiece. So that is called as a chamfering. So this is the chamfering. As like facing, this is the chamfering. So sharp edges, it can be turned into a chamfering edges. Now next operation, it is knurling and forming. So first we see knurling operation. Now knurling, in knurling operation, the surface of workpiece is made rough. Now, why we made this workpiece surface as a rough surface? For gripping, for easy gripping. So that operation is called as a knurling. So if you see, this is the knurling tool. A diamond shaped tool is there, and that same shape, it can be impression on this workpiece. So that is called as a knurling operation. So knurling tool consists of two or more hardened steel rollers which having a diamond pattern. So this pattern is called as a diamond tool. Okay. So we have a shape like this. So that pattern is called as a diamond. So this is another example. Again, workpiece is rotating in this direction. P direction, it is parallel to the axis of rotation. Again, same as like turning. And we get this diamond-like structure for easy gripping. So these patterns are formed on the surface of the workpiece by pressing the knurling tool against rotating work. So if you see, this is a knurling tool, and by rotating this workpiece, we press this knurling tool against that, and it will form the impression on this workpiece. So this operation, it is called as a knurling operation. Second operation, it is called as a forming. So the forming, it is an operation where we found or obtain a required profile by pressing the form tool. So tool which is required for forming, it is called as a form tool. The tool required for knurling operation, it is called as a knurling tool. So in forming, the required profile is obtained by pressing form tool against the surface of rotating workpiece. So the forming process or forming operation can produce concave shape, convex shape, or any irregular shape. Okay. So if you see, this is the diagram for forming operation. So we have these forming tools, different types of forming tools are there. So this is your concave surface that can be formed. This will be the convex surface, it can be formed. Similarly, we can form any irregular surface like this surface. Okay. So we require different form tools for different operation like concave, convex, and any irregular shape. So if you see, this is the forming tool which is there, and it will feed again perpendicular to the axis of the rotation of the workpiece. So this is again same diagram. So if you see, it will form like this. Okay, so it will form concave surface, or we can say convex surface. So that is called as a forming operation. Now next operation, it is grooving and parting off. Now grooving is the operation by which we make some grooves or necking. We make some grooves or necking that are produced in workpiece. That operation is called as a grooving. So if you see, this is a tool that is called as a parting tool or grooving tool is there. So the workpiece, so we can feed this and we get a grooving operation or parting off operation. Now this is required for grooving and this is required for parting up. Again, if you see, this is the grooving operation. We make a groove inside this workpiece. So this operation, it is called as a grooving operation. So here the grooves are provided. Okay. So this operation is called as a grooves or grooving operation. Now we have another operation that is called as parting up, parting off. Now parting off is the operation by which one section of workpiece is cut or parted off from the remainder sector by means of tool. That tool is known as parting tool. Okay, so parting off is the operation by which one section of the workpiece is cut or parted off from the remaining section by means of a parting tool. So if you see the operation, so here this is the one section, this is another section. So this work, it can be cut or parted off by using this parting tool. So if you see, there is small difference between grooving and parting. So in grooving, we make a groove, or we can say neck, but in case of parting, we separate out two pieces from that single workpiece. So that is called as a parting off operation. Okay. So if you see here, we can have the cutting. So from this, we can cut. From this, we can cut the operation. Full parting is there. So that is called as a parting off operation. So the tools used for these operations, that is parting as well as for grooving, they are thin, and both above operation that can be done by using feeding the tool of the workpiece at proper and at uniform rate. Okay, and it is fed perpendicular to the axis of rotation of the workpiece. Now next operation that can be performed on lathe machine, that is drilling and trimming. So first we will see what is meant by drilling operation. So drilling is the operation by which we produced hole, generally circular hole. We produce a hole in a workpiece. That operation is called as a drilling operation. So if you see, this is the drill bit. That is the tool which is used for drilling the operation. And this is your workpiece. So in case of this drilling operation in lathe machine, the workpiece is rotating and drill bit is not rotating. So drill bit is fed against this rotating workpiece in this direction. So in the direction, in the axis of workpiece, we fed this in opposite direction. That is the drilling. So if you see, generally for this drilling operation, we use the tailstock mainly. So tool, that drill tool, it is fixed into this ram of the tailstock. Okay, so that is called as a drill chuck. So here we fix the drill chuck on this dead end, and in this drill chuck, we fix the drill tool, and drill tool by means of this rotating wheel, the drilling operation that can be done on this workpiece. So if you see, workpiece axis of rotation is in this direction, and the feeding axis is also in same direction, but in opposite way. So in case of drilling, the workpiece is rotated by holding in a chuck, while drilling tool is held in a tailstock. Okay, and it is fed into the workpiece. So feeding is nothing but we have passed this drill tool, or we can say move this drill tool along the length, along this direction. Now, if you see, this is the drilling process. Now, this is the drill chuck is there, and in that drill chuck, drill tool is there. We feed this chuck against this rotating workpiece, and it will form a circular hole to the workpiece. And the material which is cut out from this, that is called as a chips. Okay, so this part is called as a chips. So in any metal removing process, or in any machining removing process or machining process, the chip formation will be there. Okay. Now we've seen the drilling. Now what is meant by reaming? Reaming operation, it can be done after the drilling. So reaming is the operation by which the dimension of drilled hole is corrected. Okay. So we have a different dimensions of drill bits like 6 mm, 8 mm, 10 mm, 12 mm. So that direct dimension, it can be corrected to the dimensions, that is called as a reaming operation. So we remove the burr part, or we can say we have operation by which dimension of that drill hole is corrected. Okay. So that tool by which this operation is done, that tool is called as a reamer. Okay. So as like same, the reamer tool, the simply we replace this drill tool by reaming tool. And the already well is there. So if you see this drill hole is already there, but we make that drill hole into exact diameter, or I can say exact dimensions. Okay, so that is done by using the reamer. Again, this is feeding process and all that is there. It is again tailstock is there, and in that we have a chuck will be there, drill chuck, and in that reamer tool will be there. Now this is similar to drilling, but reaming is more accurate. And if you see in this reaming operation, it involves very small or very little metal removal. Okay, only small particles that can be removed from that already drilled hole. So that operation is called as a reaming. So if you see, this is the reamer tool. So already drill tool is there. So only small particles it can be removed from this reaming process. If you see in case of drilling, this chip formation will be there. But here in case of reaming, only small part that can be removed. That is small particles of the metals can be removed. So these are the called as drilling and reaming operation. Now next operation, it is called as a boring. Now boring is nothing but the operation by which we can enlarge the already drilled hole. So we have already drilled some hole. Now we have to enlarge that hole. So that enlarging is done by using the boring diameter or boring operation. So here, if you see, there is already drill hole is there. So if you see, there is already drill hole, but reamer is the tool where we can enlarge the diameter of drilling hole. Okay, so this is called as the boring tool or a boring operation. Now, for boring, again same, workpiece is rotating by holding the guinea chuck, and boring tool is fitted to a tool post, is fed against this workpiece for enlarging the hole drills. Now, if you see the in case of drilling and reaming, both tools they are fixed in a tailstock. Here, it is this boring tool. It is fixed in a tool post. Okay, that is the main difference between this other types of operation of drilling and reaming than this boring and other different part of the boring. Now, if you see the boring, we enlarges only the diameter. So already drill hole is there, but we enlarge this drill hole by means of operation. That operation is called as a boring. Now, if you see, this is the operation done by the boring. So we have this cutting tool, boring cutting tool, which is fixed on this tool post, and we have already drill hole. So we enlarging this diameter of this a drill hole. So for example, if we have a drilling of say 8 mm diameter, now we require 9 mm diameter. So by using this boring tool, we can increase the diameter by 1 mm or 0.5 mm. Now, if the enlarging is done only through some length, then that operation is called as a counter. Now, if enlarging is done through whole drill process, now if the drilling is done along this length, and in along this length, boring will be done, so that operation is called as a boring. But if we done operation only in small part of the length, so only for this part of the length, then it is called as a counter boring operation. Okay, so if you see, where is counter boring? So here is drill hole, and only counter boring operation is done along this length only, not along the full length of the drill hole. So that is called as a counter boring. Now for counter boring operation, we require again boring tool, same tool required. So this is again same. So we have another operation that is called as a counter sink. So if you see in counter boring, the hole is enlarging. In case of counter sinking, the hole is as like this. So we have a drill hole, and the taper, or you can say taper operation that can be done, that is called as a counter sinking. In counter boring, this is like in counter boring. So if you see, this is the difference between boring, counter boring, and counter sink. So we'll see all these operation again in drill machines, that is drilling, then reaming, boring, counter sinking. Now next operation, that is the main operation that can be done on lathe machine, that is called as a thread cutting, or it is also called as a threading operation. So thread cutting is the operation by which threads are formed, by which the threads are formed on the workpiece. That operation is called as a thread cutting or threading. So if you see, these threads are formed on this workpiece by using a cutting tool. So this is called as a pitch, that is this distance between these two teeth. Okay, so that is called as a pitch, and this angle is called as a threading angle. So we have thread angle, pitch, all these dimensions that are required for threading. Now the thread cutting on lathe is done by using some special arrangement. Now for thread cutting operation, we require special arrangement, and we require carriage and lead screw. So these two parts, that is carriage assembly and lead screw, is required for thread cutting operation. Now this thread cutting, it can be done, if you see, this is another diagram where we can cut the thread on the workpiece. Okay, so here is the carriage assembly is there, the cutting tool is there, and by using this change in gears and that, we can have this pitch can be different for different thread. Okay, and generally in case of this lathe machine, we done the thread cutting along the external part, not on internal part. Maximally we use this thread cutting operation at the external part of the workpiece, or we can say job. So generally external threads are produced. So the special arrangement is the half nut, which can be engaged with lead screw as shown in this figure. So we have a lead screw, this half nut is there, carriage assembly is there, and there is a special arrangement by which we can cut these threads at the external part. So the engagement makes cutting tool to move through distance which is equals to one pitch. Now one pitch is nothing but the distance between this end of the one thread and this end of the another thread. So that is called as a pitch. So this engagement, so by using half nut and lead screw, this engagement makes a cutting tool to move through the distance equal to one pitch of the thread for one revolution. So every revolution, it cut one thread. That is one pitch. So this is the another diagram for thread cutting operation. So in this way, the threads are cut. So this is the operation where we cut the external thread only, not internal thread. We cut only external thread. So for obtaining different pitches, now sometimes the pitch is important things in case of threading. So we require a different pitch. So sometimes it is 1.5 mm pitch will be there, 2 mm pitch will be there, 2.5 mm pitch. So every, we can say, we require different pitches for this work. So for that, we have to change the speed of lead screw. Okay, so by which if we change the speed of lead screw, we can change the pitch of the thread cutting operation. So for obtaining different pitch on the work, the speed of lead screw is changed by engaging proper change in gears between headstock spindle and lead screw. So if you see, these are the threads. If you see here, the pitch is different. For this operation, here pitch is different. Okay. So this is the thread cutting operation. Now next operation, it is called as a taper turning. Now first we have seen the turning operation where we reduce the diameter only along the length. Now here there is a taper turning operation. So taper turning is the operation by which the tapered surface, it can be produced on the workpiece. So that operation is called as a taper turning. So if you see, for taper turning, there are number of methods that can be adapted for this taper turning operation. So if you see, in case of turning, only diameter is reduced. But in case of taper turning, the tool forms a taper. So in workpiece, it forms a taper surface is produced. And for that, we use some form tool. Okay. So if you see, first method is the taper turning by using form tool. So here form tool is used for this taper turning. Second one is, so here if you see, taper turning is done by using form tool. Next is second method, that is by using tailstock set over method. So we have a headstock center, then we have a tailstock, and the offset takes place between these two centers. So if you see, headstock headstock is here, center, tailstock center is here, and there is a set over, we can say offset or distance between these centers of the headstock and center of the tailstock, and by which we can make a taper. Okay, so taper on the workpiece. So that is called as the taper turning by using tailstock set over method. And based on this set over, the different taper at which angle which required. So based on that, we can have this setting of these distances. So that is the second method by using we can make a taper turning. So if you see, this is the second method. Now, third method is by using compound rest. So by this compound rest, we can make a taper turning. So by swiveling, or we can say by revolving the compound rest with particular angle. So if you see in this, we have this angle is there. So compound rest making this angle. So because of that, so there is a taper forming which having the same angle. So by revolving compound rest to an required angle, we produce the taper on the workpiece. Okay, so this is by using the compound rest. So we have make some angle and we make this taper turning operation, or taper surface can be formed. Now, if you see, we have seen the number of operations from turning, taper turning, thread cutting, drilling, boring, reaming, parting off, grooving, knurling, all these operations. Now we require a different machine tools or cutting tools. The most of lathe operations are done with a simple but single point cutting tools. So generally the operations like turning, taper turning, and grooving and all that, they are using a single point cutting tool. And in case of drilling, reaming, they are having a multi-point cutting tool. That tool is called as a multi-point. So most of lathe operation are done with simple and single point cutting tool. These tools are slightly varies in their shape according to the operation for which we use that operation. So for every operation, we require a different tool. Okay, so for turning operation, we require different. For forming operation, we require different. Then for grooving, we require different. For parting operation, we require different cutting tool. For knurling, same. For every operation, a cutting tool is different, but only slightly vary in their shapes. So if you see, there are some different cutting tools. So if you see turning, we use this operation. For facing, this cutting tool is used. So these both are single point cutting tool. Now for parting off, we use this cutting tool. For threading, we use this cutting tool. So for different operation, we require different cutting tool, but it having very slight change in their shapes. So if you see, there are different operations or different cutting tools. So for example, this is external thread cutting tool. Then this is the turning cutting tool. Now sometimes the internal thread it can be also generated in this lathe. Maximally we use external thread. So internal thread cutting tool is again different. The chamfering tool, if you see, this is again different. Then we have a round nose wheel tool. This is grooving tool. This is undercutting tool. This is facing tool. This is reaming, boring. So all these cutting tool have very slightly vary their slits. So these are called as the lathe tools, or tools is used for cutting or machining operation in the lathe machines. So in case of turning or facing tools, so if you see, in case of this turning and facing tools, the cutting takes place on one side of the tool only. So only one side the cutting takes place. But in case of parting of tool or finishing tool, or you can say thread cutting, the cutting of material, it can be takes place at both sides. So this side also and this side also. So if you see, in case of turning operation or facing operation, only this point by which cutting will be takes place. But in case of threading operation or parting off, the cutting will be takes place along this both edges of the cutting tool. So cutting tool takes place on or near the end of the tool. So that is called as these different cutting tools are there. So if you see, this is called as single point cutting tool. So only a point is there by which we cut the material. This is another multi-point cutting tool. Now this multi-point cutting tool, this is the milling cutter. Generally it is used in milling machine. Similarly, drill is also a multi-point cutting tool. If you see, this is the multi-point cutter is there. So that is the milling tool is there. So if you see, there are number of edges, cutting edges are there, and that will cut the material as like drill. So this is called as a multi-point cutting tool, and this is the single point cutting. So all these turning tools, external threading tools, all these are the single point cutting tool mainly. So this is another important thing. Now, if you see, there are important parameters that are used in operations performed in lathe machines. So first parameter, it is called as cutting speed. Okay, so this speed is very much important, cutting speed. So for every diameter, the speed is different. Okay, so the cutting speed is a primary cutting motion, and it represents speed at which we remove the material from the workpiece. And in lathe, cutting speed is got by the rotary motion, which is given to the workpiece, and it is calculated by equation. Cutting speed V is equals to pi dn upon 1000. That is in meter per minute. So cutting speed is in meter per minute. So D is the diameter, N is the RPM, that is the speed of the spindle. D is the diameter of the workpiece. So from that we can find out the cutting speed. Next, it is the feed. Now we seen this, all cutting tools are feed against the workpiece. So what is meant by feed? Feed determines the amount of material removed per revolution. So every revolution of workpiece, what amount of work what amount of material is to be removed, that is called as a feed. So in lathe, it is the distance moved by the tool for one revolution of the workpiece, and the direction of this feed is depends upon the operation which is performed. So in case of turning, direction is parallel. In case of facing, direction is perpendicular. So generally the feed is expressed in mm per revolution. So it is the amount of material removed per revolution. So it is mm per revolution. That is the feed. Now next important concept, it is called as a depth of cut. So a depth of cut in lathe machine, depth of cut is the perpendicular distance between machined and unmachined surface. So if you see, there is a diameter gets reduced in case of turning operation. Okay. So here is the first diameter and here is the second diameter. So if you see, this is say unmachined part and this is machine part. So this diameter is reduced. So this distance is called as the depth of cut. So depth of cut is the tool movement in the direction perpendicular to the workpiece or work surface before each cut, and it is expressed in mm. So depth of cut, it is obtained d1 minus d2 divided by 2. So diameter of first or unmachined surface minus diameter of second surface divided by 2. So that is called as a depth of. So these are the cutting parameters that are very important in case of any operation that can be performed on lathe machines. So this is all about the different operations that can be performed on lathe machines. Okay, so thank you for watching this video. Also, please subscribe to my channel and also like the video, and please share this video. If you have liked this video, please share this video to your friends so that it will got idea about this subject and about this topic. So thank you very much.